Hello, and welcome to our webinar, KIBO at Home. I'm Jason Innes. I'm the Manager of Training and Curriculum Development here at KinderLab Robotics, makers of the KIBO robot. And we really appreciate you spending a little time with us as we talk about KIBO projects at home. Now, this is obviously a really challenging time for all of us in education with schools closed, with it being very difficult to reach our students, with not being sure who has access to what materials, and of course, with distance education being screen-based, it's especially challenging for us to reach our younger students. So both as educators and as parents, I know we're all doing a lot of thinking about ways to sort of promote creative technology engagement at home. So I wanted to share some ideas for projects that you can do using KIBO, as well as let you know about a program that we have to make it possible for families to bring KIBO into their home for a short period of time, which we think might be a helpful option for families during this time of school closures. So we'll talk about those things in this webinar today. Before we get rolling, I just wanted to give a little bit of background about our company, about KIBO, and about the research behind it, because that sort of connects with the reasons why KIBO works the way it does and the reasons why the activities we're going to talk about today are structured the way they are. So KinderLab Robotics, we make the KIBO robot. We exist thanks to an NSF grant received by our founder, Professor Marina Bers. She is the chair of the Elliott Pearson School at Tufts University. Her DevTech lab researches ways to support child development goals using creative engagement with technology. So she and her team developed Scratch Junior, which is an iPad-based coding and storytelling app for young children, 5 to 8 or so. It's also a wonderful option for this time, and I encourage you to take a look at that. But her team also developed KIBO, which is an entirely screen-free robotic platform for learning computational thinking, for also storytelling, for sharing and collaborating around these STEM concepts. Dr. Bers continues to research and publish in this area, so I'd encourage you to check out any of her books and publications on the topic. But we'll zero in on some of the research that the team at Tufts has done that really pertains to this question of kind of home engagement. So one of the themes of the research that Dr. Bers and her team have done relates to this idea of joint media engagement. So that's a theory of kind of media use in a caregiving, parenting setting in particular. Joint media engagement is a way of thinking about how parents and children in particular, or caregivers and children, can consume media together in a way that's kind of healthy and learning oriented. So we can think of it as simple as the act of reading a book together. So a parent and a child, when they read a book together, there's always a sort of dialogue. The child is asking questions. The parent is sort of prompting the child to think about, like, what's this character feeling? What might this character do next? If we were to continue the story, what would we do next? What do we think the characters do next? That kind of question, that kind of dialogue is a way that the parent can engage the child in thinking more critically about the media that they're consuming together. This can apply to watching shows together. It can apply to playing video games together. And this way of thinking about the parent-child dynamic as a sort of active teaching opportunity kind of underlies the research that Dr. Bers and her team did next about this. And that's specifically about how parents and children can collaborate using creative technologies. So joint media engagement tended to look at how children and parents sort of consume media together. But one of the special things about tools like KIBO, about Scratch Junior, is that they position the child as a creator with these tools. But the parent and child still can create a dynamic together where the parent is prompting the child to sort of think more deeply, to take those next steps, And also importantly, because these technologies tend to be new to both the parent and the child, working together also gives the child the opportunity to act as the teacher. So the parent and child are able to approach the experience with a level of sort of equality that's unusual and rewarding for the child. So tools like KIBO, I just wanted to share that sort of line of research because it's important when we think about what children can do during this time of school closures and how parents and remotely their teachers can support the families. We want to think about creating experiences where the parent and child can collaborate, and the parent can do that sort of scaffolding, that helpful asking of questions that prompts the child to engage more deeply. And I don't want to lose sight of the fact also that I gave the example of reading a book together as a sort of model of joint media engagement, and we don't want to forget about that as something that we can recommend to our families if we're teachers, or that we can do ourselves with our own kids, is that reading together is always valuable, productive. It's always a great choice. And at this time, we could select books that are themselves kind of oriented around STEM, oriented around design, the engineering design process, persistence. These books that are on the screen here are wonderful examples that we lean on in our core curriculum for KIBO. And we also have a list of those books available on our website, and we'll include links to that associated with the webinar. So just briefly, Dr. Bers and her team's research that led to KIBO focused on some of these key themes, and these are going to come into play as we talk about the activities. So technologies like KIBO engage children as active producers rather than consumers. We talked about that. We also want to give young children these experiences creating with technology because at this age, it's a wonderful opportunity to expand children's own self-image as people who are comfortable with technology and engineering. We know that stereotypes around engineering and assumptions that children make about their own interest in these fields begin to form as early as preschool. So if we can intervene by giving children these experiences, creating with these kinds of technologies when they're young, we're opening doors for them, or rather keeping doors open that sort of stereotypes and self-assessments might close for them otherwise. And then finally, this idea of making coding the playground. That's a theme that Dr. Bers touches upon in her research. And it really relates to us using the metaphor of the playground as ways to think about technology experiences we're giving to children. So on the playground, children have freedom to choose their activities. They interact socially, sometimes negotiating things like rules of a game or solving conflicts together. They take risks, but those risks are controlled because the environment has been kind of prepared and created by adults for their benefit in the kind of constructivist sense. So when we think about these experiences on the playground, we can extend those to children's experiences with technology. We want to give them tools that allow them to create, to collaborate, to communicate, and also to take controlled risks. So KIBO and robotics in particular support a lot of these ways of sort of thinking about experiences children have. With robotics, children are moving around. They're interacting with each other in the physical space of the classroom. They're using arts and crafts materials to build onto and decorate both the robot and the environment. They have physical objects that they can interact with, which at this age, of course, is so important, these concrete, tangible manipulatives. And that's one of the things that we want to keep in mind as we're thinking about how to adjust to this time period and to support activities for children remotely, is we want to give them as many physical, concrete, sort of non-screen based experiences as we can. So KIBO in particular, how does KIBO support these learning goals? Well, KIBO itself, of course, is physical. It's not a screen-based tool at all. In fact, there are no screens at all when children interact with KIBO. We allow children to program the robot give instructions to the robot using tangible manipulatives. So both the coding and the robot itself, the effect of the code is something the child can see and interact with in the physical space of the classroom. The robot is also designed not to look like any one particular thing to begin with. We want children to build onto the robot, to project their imagination onto it, to tell stories with the robot, and decorating KIBO like a character or an animal or a vehicle is one of the ways we give them that hook for their imagination and also interest children who respond as much to the sort of art and building and storytelling as they do to the technological side. So the robot itself is made for children to interact with. All of the parts can be removed and reassembled by the child easily without any adult assistance, but it also provides a platform that the child and parent can sort of work together around as they kind of figure out what the different parts do, how it might fit together. Again, that joint media engagement, that idea of the parent asking the child to talk about what they're doing, think about what they're doing, share their impressions of the object and of the tasks. That all is facilitated when the parent and child are working with a physical object together. We want children to see that they're part of this engineering process that's involved in creating the robot. So the robot itself, they can see the inside of the robot in order to get this impression that maybe we don't know how all of these parts work at first glance, but we see that it's not magic. KIBO is made of wires and batteries and circuit boards. And then the child becomes part of that engineering process by attaching things like the wheels and motors, the light bulbs, the sensors. And then the child is also able to engage with the physical manipulatives that make up KIBO's programming language. So when we create a program for a computer or a robot, we're creating a sequence of actions, an algorithm from a beginning to an ending. And in between are the steps that the robot will act out when it runs the program. So for KIBO, for making these concepts, which are somewhat abstract, making them more accessible to young children, Dr. Bers and her team developed these wooden blocks where each block represents one step in that algorithm, one action for the robot to take. The child creates a sequence by attaching the blocks together, using the embedded barcode scanner to read each block one at a time, and then the robot acts out the sequence. So all of these ideas kind of come together as the child uses the robot as kind of a platform to tell a story, to explore an interest, to share an idea. And that's really the heart of it, is that coding, robotics, creative technology are really tools for the child to create and express herself or himself. So that's why the arts and crafts become such an important part of the experience with KIBO, is that KIBO is never just a robot traveling forward and backward and turning. It's a dancer that might express like the movement of dancing to the music of some other culture that the child is very interested in, or that draws upon their own family's history. KIBO might be a vehicle that explores a town that the child's room has sort of transformed into thanks to their imagination. So building onto the robot is how KIBO becomes a character, and how the programs go from just an algorithm, a sequence of steps, to an expressive story that the robot is acting out. Okay, so then that's how we might frame the experience that children have with KIBO. So let's talk a little bit about how we might help parents sort of bring KIBO and experiences like this into their home, and then a few activities on other resources that we can use to help support them. So I wanted to share information about an option that KinderLab Robotics has for enabling home use of KIBO. Of course, KIBO is available for purchase by parents or grandparents or other caregivers for use at home. And many people do buy KIBO for home use. But there are many parents out there who would like more support in how to present these ideas to children, how to engage with children in order to kind of maximize the benefits that we were just talking about. And as educators, we also want to make sure that parents, when they're engaging with their kids around these STEM activities, that the parents have these resources too. We've developed a 3-month program based on KIBO called the KIBO Home Robotics Course. So it's a 3-month program intended for families, caregivers at home. In the program, the family receives a complete KIBO kit for 3 months, along with a curriculum that we've developed for use at home, and a series of kind of supportive emails to keep the parents and the family on track. The children walk through a sequence of lessons with the parents' support that introduces the entire kind of scope and sequence of learning concepts with KIBO. So everything from how the engineering design process and sturdy building to the simplest of algorithms, how we create a simple program with KIBO. And the sequence takes kids all the way up to using KIBO's more advanced sensor parts, the distance sensor, the light sensor, the sound sensor, to create complex conditional programs with repeat loops and if statements. All of this is contextualized with activities that draw on that sort of imaginative play and storytelling theme that we just talked about. The program costs $169, and it provides that 3-month use of a complete KIBO kit. The family receives all of this curriculum, some supporting materials like activity cards and engineering workbooks, and this weekly check-in email series to kind of guide them through the curriculum. So this is something that a family can kind of participate in relationship with KinderLab directly, or it's something, if you're an educator, it may be something that you could encourage your families to make use of, and then you can sort of support that weekly check-in email through your own contact with your families during this kind of distance learning period. So there's a couple of different ways that this can help your families be successful. So let's talk about a couple of activities that we might find through that curriculum. And these are activities that you can think about using in your own family, whether you use the program or not, or that you might suggest that your families engage with if they have access to a KIBO. We can create simple games with KIBO. So we might create a bowling alley using plastic pins or maybe empty water bottles. Really anything will work. But the essence of the activity is to ask children to create a movement program for KIBO that will travel the whole length of the bowling alley and knock the pins down. You can make it a straight bowling alley. You could make it have obstacles so that there's a problem-solving component. But the heart of it is also getting children to understand that relationship between the sequence of actions in the algorithm, the movement program, and the movement of KIBO in the physical space. This is a great game-based way to introduce that idea of an algorithm. Let's widen the lens a little bit though. Once children have that idea of an algorithm, a sequence of the KIBO commands representing a sort of story that the robot will act out, we can make that connection explicit with the arts and crafts component. So let's have KIBO be a character in a story, and we'll create a program to allow KIBO to act out the scene in that story, what happens, what the character does during that scene. So we know that one of our goals, getting back to that idea of joint media engagement with reading, one of our goals as we read with our children is to get them to really engage critically and imaginatively with the sequence of events in the story, the motivations of the characters, really putting themselves sort of into the story to show that they kind of understand the sequence and the intention of the characters in the story. So one great way to do that is to ask them, well, in our favorite story that we just finished, what would happen next? Can we create our own sort of next chapter of this adventure between, say, Piglet and Pooh, or whatever story the children are interested in. They can decorate KIBO to look like that character and then extend the story through their own imagination, creating a program to have KIBO act out that sequence. Movement is really important during this time. We know that, I mean, one of the simplest goals of a screen-free tool is to keep children moving. We know how important it is to get physical activity, but also for this age group, movement, gross motor play, engaging with physical objects, these are all critical to the learning process itself for young children. Young children learn best when they have the opportunity to simply move around. So what if KIBO becomes a dancer or a singer? We choose children's favorite song, create a program to have KIBO dance to the song, and then we can all, the child, the parent, whoever's at home, can dance along with the robot. So we can sort of bring this together as both a problem-solving, critical thinking exercise of creating the dance program for KIBO, but a movement activity as well, where the children get, or the child gets up and dances and moves around as well. Maybe children are spending a lot of time with their pets, or maybe they're thinking about pets that they would like to bring into the home. That one easier way to do that than actually bringing in a new pet into the home at this time might be to ask the children to decorate KIBO like the pet they imagine bringing in to the home, and then imagining a trick that they would like KIBO or their pet to do when they clap. So we can use KIBO's sound sensor as part of a program to have KIBO trigger a behavior when it hears the child's clapping sound. So again, this creates this sort of role-playing, storytelling dynamic where the child is imagining the feelings, the experience of this character that he or she is creating, and then using KIBO to act out, to make real that imagined creation. So teaching our KIBO robot a pet trick is really a way to sort of allow the child to explore this interest in their life using coding and robotics as the way to express themselves. And that's the heart of that sort of theory behind why these tools are so important to children. We're giving them a new literacy, a new way to express things that matter to them. So just a few other sort of fun activities that are that work really well at home that I wanted to share with you. These don't actually come up during the curriculum of the Home Robotics course because they require add-ons to KIBO that aren't part of that core scope and sequence, but they're really fun tools. And if you have access to a KIBO at home, either through that program or your own KIBO, these may be things that you want to think about bringing in. So one of the add-ons that we have is an adapter to allow KIBO or allow children to connect Legos to KIBO in various ways. So they can attach Legos to a spinning platform that goes on top of KIBO, like the wooden platforms that come with the basic kit, or these Lego platforms that attach to the sensor slots like you see in the image here. So that really extends and opens the door for building projects with KIBO. It works with Duplos as well. One example of an activity we could challenge children with is to build a really efficiently shaped plow and connect it to KIBO in a sturdy way so that KIBO can clean up the cotton ball snowstorm. But really, building onto KIBO is just another great way to engage that sort of imagination play and storytelling, but connected to a little bit more of an engineering theme, since Legos are such great versatile building tools. The Lego free throw, or the KIBO free throw attachment is essentially a throwing arm that allows KIBO to throw a ping pong ball. So that's from a sort of school point of view, we can talk about the ways that this gives children a sort of hands-on experiential introduction to physics concepts like trajectory and arc and power. But we can also just think about this as a way of supporting all kinds of play-based learning with KIBO. So we could challenge kids to a game of bin ball where we ask them to have KIBO navigate a course up to a sort of free throw line and then try throwing the ping pong ball into a target like KIBO's empty bin. So this is another way to sort of bring a play-based sort of spirit into the programming challenges that we engage children in. And then finally, we have an attachment that allows KIBO to hold markers as it moves around. So as KIBO moves and acts out the children's program, KIBO will draw as it moves, and different kinds of turns, different positioning of the markers will cause all sorts of different kind of line qualities and shapes to emerge. This, again, sort of pedagogically, this is a great way to allow children to kind of see visually a concrete representation of the program they created. So when they ask KIBO to drive forward, they now have a line on the paper that represents that distance that KIBO traveled when it acted out one forward command. So this is another way of making programming kind of more concrete and tangible for young children. It's also just a really fun, interesting way to make all kinds of crazy drawings that nevertheless kind of correspond to the program the child made. So can we challenge the children to invent a program to draw a square? Or if we make an infinite repeat loop with a lot of spins and forwards, we can make sort of spirograph style drawings for those of you among the audience like me who are old enough to remember a spirograph. So making KIBO draw is a simple way to create a whole nother dimension of engagement where the child can see the effect of the program that they created. So these options that I just mentioned, the free throw, the Lego, the marker extension set, those are all available from the KinderLab store. You can buy them all together in our add-on fun pack, we call it, and those can work with any KIBO that you have. So that's an option to just add more kind of depth of engagement to a KIBO that you have, either your own KIBO or one through the Home Robotics rental program. Okay, and then finally, I'd just like to close with a couple of free PDFs that you can get from KinderLab. We'll also make those downloads available as part of the follow-up to this webinar. But these activity PDFs can give you some resources, especially if you're an educator, resources you can share with your families. One of them doesn't even require a KIBO. But these some resources that you could download from KinderLab today. We have a set of 22 activity cards. Each card introduces a new part of KIBO or a new command or programming concept. They're meant to be engaged with primarily by the child with the assistance of a parent or teacher. So they work well in a classroom in an activity center, but they also work great for home use where a parent and child can engage with each of these activities one by one together. We have a PDF of sort of larger scale activities similar to the ones that I covered already, the KIBO Pet or the KIBO Dancer. This booklet is all activities that make use of movement of KIBO in an environment. So we call it our maps, measurement, and make-believe. So it's activities based on sort of floor maps where KIBO is playing the part of maybe a vehicle or an explorer or an animal in an environment that the child creates. So this is a free curriculum PDF, and the activities are great for a joint project between a caregiver and the child. And then finally, I mentioned that we do have a resource for families that don't have access to a KIBO at all. So if you're a teacher and you're looking for resources to offer to your families, and those families don't have a KIBO and you don't think the Home Robotics course is a good choice for them, this booklet called No KIBO, No Problem is 4 different STEAM activities that don't require any KIBO at all. So you can do most of these activities with materials that are available on hand. So this is something you can share with your families. So all of those downloads are available from the KinderLab website, and we'll share those links. So again, just to kind of review the benefits of sort of STEAM learning at home with KIBO is this focus on sort of STEM learning through this playful engagement. The fact that the robot and the experience is entirely screen-free helps support sort of our goals for limiting screen time and encouraging physical movement. This idea of joint engagement is so important, where giving these opportunities for the parent and child to work together as kind of co-learners who are prompting each other. And then finally, this theme of creative expression with technology that underlies really all of the pedagogy behind KIBO and the research behind KIBO is this, we want at this age to give children experiences creating with these tools, telling stories, sharing their own interests, so that they see themselves as able to engage with these kinds of tools and these explore these interests as they move on through early childhood into elementary school. So thank you again very much for joining this webinar. We're, like you, we're continuing to sort of try to find ways to support our learners during this difficult time. We encourage you to share your experiences with us. You can tweet at us at KinderLab Robot. And then I'd encourage you to take a look at this webpage that's on the slide here, kinderlabrobotics.com/@home, for information about some of these resources I've mentioned, and in particular, the 3-month KIBO rental course, the KIBO Home Robotics Course. So thank you again, and I'm Jason Innes, KinderLab's Manager of Training and Curriculum Development, and I wish you all the best and stay safe and keep in touch. Okay, thank you.